你想成为一个名副其实的白领吗？你想拥有一份令人羡慕的高薪工作吗
？You're encapsulating the Cisco frame as we see flag, address, packet type, data, FCS, and flag. Now we're able to do that, like I mentioned earlier, between Cisco devices. So if I'm running from this device over to this device, it's no problem. But if I have a third vendor here, some other vendor that is not Cisco, and I need frame relay to exist here as well, I'd have to use the IETF form. Regardless of which type of encapsulation you use, the most important function of these frames is the addressing section here that is going to let you know what DELSI is associated with that particular frame. And the DELSI is the equivalent to the MAC address in most local area network connections. In other words, it's the layer 2 identifier that you're going to find for addressing. Now, what we're going to have is a DELSI that is significant or unique per physical channel, which means that virtual connection that you have here, a DELSI will not exist across that entire virtual connection. It's going to exist on the physical channel, which is from the switch within the frame relay network over to your router that interfaces with that switch. So your DTE to the DCE at the frame relay network, this channel, a DELSI exists here. So that means that another DELSI will exist between the switch and the other end that you're communicating with over here at R2. Another name for this physical channel is the access line, as we define it in the frame relay terminology that interfaces the DTE to the DCE. Alright, let's take a look at the frame specifically. This address portion we're going to break out and show in more detail here. What we're going to have is 2 bytes, which is the equivalent of 16 bits, right? So we have to number those. We're going to have 1 through 6 here, 7 and 8 available at the end, and here we're going to have 1 through 4 in the second byte, then 5, 6, 7, and the 8 bit represented here. This is what we're going to have within those pieces or fields within the address. Specifications have been written for this data link connection identifier to be represented in different lengths, but the standard or default length is 10 bits long. And that's why we see within our address field here 6 bits for the high order bits of the DELSI, in other words the first 6, and then 4 bits after that to complete the rest of the DELSI. And these are called the low order bits of the DELSI. The rest of these fields will be defined in the Advanced Concepts Frame Relay Nugget. They are the CR. These have to do with error notification. This is the discard eligibility, and these are the extensions, EA. And again, those will be explained in more detail in a later nugget. Alright, for now, let's continue to define the DELSI. Another thing about the DELSI you need to know is its range. You can range between 16 and 1007 when you're talking about local significant DELSIs. So let me explain what I mean by local significance. Within a frame relay network, whatever I assign as a DELSI to identify this pipe or this virtual circuit is going to be unique only in the fact between this router and this switch. It doesn't matter what happens between this router and this switch. There is a division here. So that really means that I could have a DELSI here of 16 and a DELSI of 16 on this end as well. This poses no problem for the frame relay network because remember, DELSI has significance from the DTE over to the DCE. But in most cases, even when we're dealing with locally significant DELSIs, they will be different on each end. So let's say that this here will be a DELSI of 26 while the other is 16. This idea of locally significant layer 2 addressing is probably the biggest hurdle to get over in frame relay networks, especially if you're coming from a LAN environment where layer 2 addresses have to be unique on the individual devices. So let me give you an analogy to help carry you through this. Let's say we have a target here. Transmitting data down a frame relay network interface off of a router is much like target practice with a gun. Alright, I'm going to draw my gun here, no laughing. At the end of the gun, I have a sight here, and it's used for aiming at my end target, and then I fire into the target. Now this illustrates the IP address at the distant end. In other words, the IP address that exists here, if I'm transmitting out of router 1 across this frame relay network to this distant end. Now the site is going to represent my DELC. Understand that that DELC resides locally. In other words, it's on my gun, on my interface, and it's used just so that I can aim straight down that virtual connection that exists from end to end. Let's take a trip back into the router so that we can complete the second of the 2 mandatory commands to make basic frame relay work. Remember that the first one was we find a serial interface and we set its encapsulation type to frame relay. Now what we need to do is set up the DELC on that interface. So here we go. I'm going to get into conft interface serial 0, and at this point I'm going to type in the command frame-relay interface. Now there's no abbreviation of interface because there's a second part to this little line, DELC, and now I can pick anywhere in my range, let me hit the question mark, between 16 and 1007, just like I showed you on the whiteboard. In this case we're going to opt for 201. You hit enter, Control Z, show the running config, and what we're going to see is both commands that we need for frame relay setup. Let me hit advance here, and there they are. DELC is 201, encapsulation is frame relay, and they all exist on the serial interface. We started this nugget by looking at the history that led to the development of frame relay. Then we looked at terminology and devices that are involved in a frame relay network. Encapsulation was covered after that, and we just went over the DELC. Now we're going to look at the committed information rate. The committed information rate, again, exists between the access line from the router, which is a DTE, over to the switch, which serves as our DCE. So in this respect, it shares the same boundaries as our DELC. Alright, now what is the committed information rate? It's the guaranteed minimum bandwidth at any given time that will be supported between these 2 points. Let me give you an analogy to try to help explain this. Let's say that I have a neighborhood here with 3 homes. And that neighborhood is serviced by a central office, or a dial central office from the telephone company for its telephone connection. So each one has cabling to the home, and they can support 1 phone call at a time on their 1 telephone cable. We will define these 3 units as